And we are live. What is up, everyone? Welcome back to the HackSmarter Twitch channel. My name is Tyler Ramsbey. Whether you're watching this live as it happens or after the fact on YouTube, truly it's an honor to have you take the time to hang out with me and learn some AWS with me. Now, this is kind of a surprise stream. Usually I am on late at night, but right now it is during the day. One of the reasons I'm on late at night is because my kids are asleep and I'm much more of a night person. Like until about noon, I'm about half awake, but had a chunk of time here this morning before my workday really gets started. And because I'm not going to be on stream tonight, I have a family event going on. I wanted to jump on stream and at least spend a little bit of time going through the pathway. So a few caveats as we get going. As I said before, usually I'm on at night because my entire house is quiet. During the day, I work from home. I have kind of an office set up in my basement, but my wife, my kids are above my head. So if it sounds like thunder or a construction zone, it's my kids. Although that being said, I don't think this microphone picks them up. I think it does a pretty good job of picking me up. But if you do hear noises in the background, that is what it is. And if I make silly mistakes as usual, it's because it's morning and my caffeine hasn't quite kicked in. So all that being said, let me go ahead and share my screen and show you guys where we are picking off at. We are working through the Attacking and Defending AWS Learning Pathway on TryHackMe, which is a business-exclusive pathway, but I've received access for 1 month and received permission from TryHackMe to live stream the entire thing. So my goal, don't know if I'll be able to do it, but my goal is this month, I want to work through this entire pathway and record every single part of it, every text, every word that I read, so that those without access to the pathway can still learn. And it's kind of like we're sitting down at a computer working through this together. For those of you on Twitch, I do want to say a special shout out to Pluto and Andreas, I'm probably saying that wrong, and about 20 other people watching live who haven't said anything in the chat. Thank you guys for hanging out live. Do appreciate it, and also welcome to those on YouTube. Andreas on chat said, glad to see you online during the day. I know it doesn't happen very often. What was the name of the song playing before you started? That song was called Bullet by NF. If you just look up NF, he is an incredible artist. This guy right here, NF. Check him out. I'm often playing music off of his new album, Hope, so that is what you were listening to. Explosion said, first time here, a long time lurker in the Discord, though. Sweet, my friend. Well, welcome to the official HackSmarter stream. I know often it's, for those of you in a different time zone, even in my own time zone, I'm often not on stream till like close to midnight. And so I know many of you are asleep at that time. I don't usually have a chance to jump on during the day, but here I am. I do just need to keep my eye on a few things for work, but I should have at least a chunk of time this morning to hang out with you guys and keep working through this pathway. So let's dive into it. So far, what we have covered is the introduction to AWS and a bunch of IAM information. Today, we're going to dive into IAM credentials. Now, if you missed any one of these streams, what I am doing is I record these on Twitch is I'm releasing a module each day. So I've released this one, and then I just released this one today, and then each one of these will be coming out. So over in the chat, I'm going to post my YouTube link just for those of you who maybe have not subscribed to me on YouTube. And if you get behind or want to watch the recordings, you'll be able to find them all on YouTube. You cannot find my content here on Twitch. So I think a few of you, even yesterday, were like, hey, Tyler, it's been a while since you've been on. I'm actually on Twitch pretty often. You just don't see my past broadcasts here on Twitch because Twitch doesn't like my music. It's like, hey, that's copyrighted, blah, blah, blah. Even though I don't have monetization or anything turned on Twitch or YouTube, Twitch doesn't like it. So you can't find my past recordings here on Twitch, but you can find all of them on my YouTube page. So I would encourage you to go to my YouTube, subscribe there, and you can follow along there if you ever miss one of these live streams. All right, let's dive right into IAM credentials. So every call to AWS is authenticated in some form. For the API, this is typically done through request signing. However, when using the AWS console, you log in using a more traditional username and password combination. In this room, we'll dive into the various ways you can authenticate to AWS and best practices for securing your AWS account and passwords. And so we are going to access the environment. In the past stream, I just shared my screen as I did this, but technically y'all would be able to log in. So I regenerated my environment, and just when I pull up these creds, I am going to stop sharing my screen while I get logged in. So just give me 1 second while I pull up the cloud details, and just need to type in my username. Oh, okay, there we go. I think this is all correct. 05. Okay. Throw that to the side of the screen. Get this pulled up. All right, I'll go back to sharing my screen. All right, and we are back into it. So I have access to our cloud environment. I have the Cloud Shell here, and I have my console right here. So this is just explaining how to access the environment, which I just did. So we will hit complete on that. The root password, the first set of credentials we will discuss is the most powerful, the login password for the root account. This is the password you create when signing up as an AWS customer for the first time. There are very few limits on what the root user can do, so this password should be secured. If your AWS account was created before 2017, this password is also your Amazon retail password, so don't share your password. Unless it's Netflix, you can share your Netflix password. You heard it here. If you use AWS organizations and created the AWS account via the create account API call, then the root password is a randomly generated string. AWS doesn't return that password when an account is created via AWS organizations. To log in as root, you will need to do a password reset. To log in as root or reset the password, you must use the main AWS sign-in page. There you'll be prompted to log in as an IAM user or the root user, and you can see here how to reset your password. Certified that we are not a robot. Are we a robot? No. So far, so good. The login profile is AWS's term for a user's console password. Not all IAM users have access to the AWS console. The AWS console uses the term console password, while the AWS CLI and APIs use login profile. To grant an IAM user access via the AWS console, you can do it from the user security credentials tab or via AWS CLI. And yo, what's up, Amoeba Man? Good to have you here, my friend. He says, finally a stream, not at crazy times. Yeah, I suppose 9 a.m. my time zone is a much more doable time for where you're at. Let's keep going. So I love this example right here. We're setting the password, to the very secure SolarWinds 321. You can use this command to change the user's password. Very simple there. And AWS allows an account administrator to set a rudimentary password complexity policy. You'll find this setting IAM under account settings or via the CLI. So last night when I was originally working through this on stream, I actually stopped the stream. I was having some issues with my environment, had to reset my environment. But one thing that wasn't working was this command in the CLI, and I still don't think it's working. But we can get the information from the console itself. Yeah, I think this is because there's no custom default password policy set. It's just like the default password policy. That's my only guess at why that command doesn't work. Because I believe if we do it this way, we can check this out. So we can see it's using the default password policy. So that's why I think that setting's not doing anything. If there's a custom password policy set, I believe it would have returned some information there. Here's a question. What is the minimum number of numbers? Pay attention to that. Numbers required in the password policy. All right, so password strength include a minimum of 3 of the following mix of character types: uppercase, lowercase numbers, and non-alphanumeric characters. What should stand out to you is notice it needs 3 of these. So you could have an uppercase letter, a lowercase letter, and an alphanumeric character. You don't technically need numbers. You need 3 of the 4, not 4 of the 4. So the minimum number of numbers would be 0. You don't need numbers. Amoeba Man said, can you change the password policy to test? I don't think so. Let's find out. See if I have permission to do it. So we'll try to change the password policy. We'll just say, hey, we want a minimum of 7 characters, and we'll make that one change. This will impact any new user creation. Okay, yep, whatever. Yep, so I don't have authorization to update the password policy on this resource. I believe the way the pathway works is as we get to other modules, we receive different permissions in AWS, but our current AWS account, we just don't have permissions to update the password policy. I suppose, what I could do even offline, I have my own AWS Sandbox account. I could go mess around with my own AWS Sandbox account and see if that's the case. But that's just my guess. So one thing to note for TryHackMe, I don't think this command works as written unless there's a custom default password policy, but might be completely wrong on that. I just haven't gotten to work even after resetting my environment. All right, AWS API access key. AWS access keys are the primary method of interacting with the AWS API. Even the AWS console, let me get this pulled back up. So we have our command shell here. Perfect. Okay. AWS access keys are the primary method of interacting with the AWS API. Even the AWS console uses access keys on the back end. You'll be able to see this when we dive into our room on CloudTrail. There are two types of access keys, long-term and temporary session keys. Long-term access keys begin with the string AKIA. They do not expire, but it's best practice to rotate them regularly. You can imagine if your access keys are compromised by an attacker and you don't rotate them, they have access to your environment long-term. A long-term keys consist of an access ID and a secret access key. Only IAM users or the root user can have long-term access keys. However, best practice is to never generate access keys for the root user. The root user or an IAM user can only have 2 access keys at one time. You cannot set the access key ID or secret. They are always generated by AWS. Long-term access keys can be active or inactive. You can disable access key via this command. And once again, I was trying these commands when I was first testing my environment. These commands don't work because we don't have permissions to run them. So I believe these are just examples here. If you need to re-enable the key, so we have update access key. We're just changing the status there. That's the only thing we're changing there. And to delete a key, we can do, instead of update, delete access key. Once deleted, a long-term access key cannot be recreated. Session keys have an expiration time, kind of like a JWT, after which they are no longer valid. Session keys also have an access key ID and a secret access key, but they also have a long session token. The session key ID begins with ASIA as they are temporary. AWS session keys cannot be deleted or disabled like long-term keys. Trivia. IAM has many different identifiers which are documented here. Long-term credentials can be created via the AWS console or the AWS CLI. And you can see this here, and I'll just show you that we don't have permissions to actually do this. So we do AWS IAM create access key username student. Did I just type it wrong? Oh yeah, I did. I typed username wrong. Okay, we're not going to retype that. We're just going to copy it. So you can see it is actually kind of helpful to read this error. What's going on here? Well, it says an error occurred when calling the create access key operation. So we talked about some of these operations here. This specific operation is one we talked about in a previous module. And it says our user, it gives us our ARN right here, is not authorized to perform. Here's the action on, here's the resource, the user student, because no identity-based policy allows that action. So actually, we spent a lot of time in the last stream reading policies and seeking to understand policies. So if you join me for the last stream, and maybe you watched the last YouTube video if you're watching this on YouTube, hopefully that error message makes more sense than it initially did before we started learning about AWS. Short-term keys are only provided when requested, and there are numerous ways AWS can provide those. They are generated by the AWS Security Token Service, abbreviated as STS. The most basic way is to get a session token. I think I can type this command. I don't remember. No, okay, so I can't do that either. My user does not have permissions to do that. So here's the question. How many active IAM access keys does the TryHackMe IAM user have? Well, one way we can check that is if we go over to users. Here is the TryHackMe IAM user. We'll click that. And if we go to security credentials, I only know access keys well because this is how you set up CloudGoat, so I've done this many times. We see 2 sets of access keys. Here's one right here, and here's one right here. The question says how many active. It bolded that for us. You'll notice this one is inactive, whereas this one is active, so I'm going to say 1. There we go. MFA in AWS and best practices around credentials. Get our Cloud Shell pulled back up. AWS supports using a virtual MFA, hardware token, or UTF security key. The last 2 links are the Amazon RealTL pages for the products. MFA can be applied to either an IAM user or the root user. When using an identity federation to assume an IAM role, implementing MFA is a responsibility of the identity provider. When MFA is applied to an IAM user or the root user, AWS will require the second factor when performing a console login. MFA is not required by default when making an AWS API call using access keys, and this is why it's so important to rotate those access keys and to protect those access keys, because if me as an attacker get access keys to your AWS environment, your MFA is not going to stop me. Even if you have MFA enabled on your console login, it's not enabled by default when making an API call. However, IAM policies can implement conditions to require MFA. That would be a good idea. To do this, the user must first request temporary credentials and pass the MFA token as part of the request. The new temporary credentials will have a flag that says MFA was present when they were created, and the IAM policy condition will be satisfied. Mishandling of AWS credentials is the primary way an AWS account is compromised. There are several best practices for handling AWS access keys that you should follow. Number 1, avoid using IAM users wherever possible. Many cloud providers offer the ability to use SAML or OIDC to get session credentials for AWS API access. 2, never commit an access key to a source code repository. GitHub, GitLab, Twitch. GitHub will scan all commits to a public repository for any AKIA and notify AWS, who will promptly disable the key. But even private repositories can be compromised, and attackers know to look for AKIAs in source code and configuration files. 3, rotate access keys often. When creating an access key, you have the option to download the credentials as a CSV file. These CSV files collect and download folders. If machines are not properly cleansed when decommissioned, or a laptop is left in a taxi cab or an Uber, these credentials can find themselves for sale on the dark web. And finally, use MFA. Always use MFA for access to the root and IAM users. Many of the IAM identifiers can be useful from a reconnaissance perspective. For example, AKIA strings, while not sensitive, so that's the access key strings, can be used to identify an AWS account with the following command. So any AWS account, if we have the access key, we can identify it. So which user has MFA attached to it? And it says, hey, just run this command. And this is the most confusing thing, in my opinion, about learning AWS, is just there's not consistency to how you enumerate different things. So it's a lot of asking ChatGPT, but you can see we're just doing AWS, IAM, and then list virtual MFA devices. And if we do that, we can see we have, here's the serial number of the virtual MFA device, and we can see the username it is applying to, and that's this one right here. All right, what account ID does this belong to? So if we consider the account ID aspect of it, we just need to copy this command in. We'll type it in, AWS STS get access key info, access key ID, and then we'll grab this account ID, paste it in there. And here is our account. Let's go ahead and copy that, and we'll paste it in. Beautiful. How services get credentials. As we noted in the section on IAM roles, AWS services can also leverage temporary credentials to access resources in your account. The roles assume role trust document must specify the service as a principal allowed to assume the role. The mechanics for getting these credentials vary depending on the service, but when you're attacking or defending cloud infrastructure, knowing how to get these creds is vital. The primary way to get the credentials for a role is with AWS STS assume role API call or the AWS STS assume role AWS CLI command. If you're using an EC2 instance, remember that's just AWS's fancy name for a virtual machine, there's a special network address in the hypervisor you can use to request temporary credentials for the EC2 instance profile. It was through this instance metadata service that the Capital Run breach was executed. This is actually something we still see in the wild. Even if I'm doing like a web app pen test, sometimes I'll realize I'm on like a EC2 and I'm able to actually query this and get access keys. In a future room, we'll show you how to curl to that. That's the metadata endpoint. It's technically an SSRF attack, which will present temporary AWS access keys. As a response to the Capital One incident and outcry from the cloud security community, AWS released IDMS v2, which requires a two-step session-based method. If your code is running AWS Lambda, the access key, secret access key, and session token are available as environmental variables, which you can also get SSRF and I believe query for that. For ECS containers, there's another IP you can curl for the container's credentials, and you can see it right there. We're passing to this. There's actually a CloudGoat scenario where this is the way you get credentials. The AWS container credentials relative URI environment variable is populated if IAM roles for tasks is configured. Finally, you get temporary credentials from your Cloud Shell with this simple command, and this is actually with the version 2 enabled. So when version 2 is not enabled, you can literally just do a curl request for this, and you're able to get credentials. When version 2 is enabled, what you need to do is pass an authorization token, and here we're using a variable to grab it, but you can, if it's not properly secured, you can still get AWS credits even with version 2 enabled by curling it this way. I think we are going to do that actually. So if we do this, use the Cloud Shell, which we did, and the curl command above to download temporary credentials. What is the JSON key that begins with E? Well, if you look at this, the JSON key that begins with E is expiration. So we'll go ahead and grab the expiration key. And then when using temporary credentials, what are the first 4 letters of the access key ID? And if you remember when we were talking about this, the temporary access key always begins with the ASIA, and we can see it right there. That's how we know these are temporary credentials. So we'll copy that, and we will paste it in. And there we go. That concludes the IAM credentials room, learning how IAM handles credentials for authentication to AWS APIs. Although this was, of course, a shorter video, we will continue this, but for those of you on YouTube, this is going to be the end of the YouTube video. For those of you on Twitch, what we'll do is let's take a 5-minute break, get up, do jumping jacks, run around, do whatever you want, but let's take a 5-minute break, and at the end of the 5-minute break, we will dive right back in, and we will continue working through this room. So I will be back in 5 minutes.